Okay guys, let's talk about the weak and strong electrolytes. In the past videos we discussed about the concept of electrolysis in the various terms related to electrolysis. So here we're going to see these types of electrolytes that can be weak or strong electrolytes. Now let's start with the weak electrolytes. These are compounds that are only partial or slightly ionized in the aqueous solutions. Now, substances, for example, ethanoic acid solution ionizes partially. As you can see in the equation, it ionizes partially to give these hydrogen atoms. So, hydrogen ions. So, it doesn't ionize completely. So, any electrolyte that it does not ionize completely is what we call the weak electrolytes. Also, a solution of ammonium water is a weak electrolyte since it contains a relatively small portions of ammonium and the hydroxide ions after the decomposition or after the electrolysis processing. Most of the organic acids are the weak electrolytes, for example, tactaric, citric, and carbonic acids. What is also weak electrolyte since it ionizes only slightly. As you can see, the ionization of water gives the hydrogen ions and these hydroxide ions. So, yes, ionizes partially. Moving on. Let's see the strong electrolytes. The strong electrolytes, these are compounds that are completely ionized in aqueous solutions. So when maybe, for example, a sodium hydroxide is dissolved in adequate water, it ionizes it completely into these sodium ions and the chlorine ions. Now these are no, there are no sodium chloride solid particles left ionized. So basically, the sodium chloride ionizes completely. This means that there are no leftovers. Now, all the strong electrolytes, the salts, the amino acids, and the caustic alkalis ionize completely in solutions. So that's about the strong electrolytes. Let's see the mechanism of electrolysis. Now, here we're going to see how electrolysis happens. Now, the conductivity of ionic compounds is explained by the fact that the ions move in a particular direction in an electrical field. Now, this can be shown in experiments with the colored salts, for example, maybe copper 2 chromate 4 that dissolves in water to give a green solution. Now, this solution is placed in a U-tube, as we're going to see that in a U-tube. Now, this solution, the current solution of this dilute hydrochloric acid is then layered on top of the salt solution in each arm in each loads. The graphite loads are fitted as shown in the following figure. These are the graphite loads. The graphite loads can be the graphite cathode and the graphite anode. Now, the loads carry the current into and the loads also carry the currents out of the solution. So after passing the current for a short time, the solution around the cathode becomes blue. As you can see in the diagram, that is the color becomes blue, and around the anode the solution becomes yellow. Now these colors are produced by the movement or the migrations of the ions in the salt. Now the positive copper ions are what are in blue solution. They are attracted to the cathode, the negative electrode, and the negative chromate ions are yellow in solution, so they are attracted in the anode, the positive electrode. So generally, we can say that the positive ions are attracted to the negative electrode, while the negative ions are attracted to the positive electrode. Now, the use of colored ions in solution has shown the direction that positive and negative ions move in the electric field. Always positive ions cations move to the cathode, and the negative ions that are anions move to the anode. So that's all for this video. I hope it's clear. We've seen the weak and the strong electrolytes. We've discussed shortly about the mechanism of electrolysis. Thank you.